All right, this is the key to test number 2. Okay, so number 1, and this is a multiple choice question. So number 1, you wanted to determine which of the following are functions, and it says select all that apply. All right, so you have two graphs of relations, and then you have a set of ordered pairs, and then you have two equations. All right, and so you need to determine which one of these represented a function. Okay, so number A and B, in letters A and B, you could have used a vertical line test to determine that. A vertical line test. And so if you notice in, let's say, B, if you draw a vertical line in an infinite number of places, it has to be at least one place, and at least one place, this vertical line intersects this graph in more than one point. So that means that this x value right here, there are two y values. And remember, the definition of function says that for each x coordinate, there can only be one y coordinate. So when x is this value, there are two y coordinates. This y coordinate and this y coordinate, and so on. So there are infinite number of places where that happens, but you just need it to fail at one point, at one place. Okay, so this is not a function. Over here, though, when you draw a vertical line, no matter where you draw it, where you draw the vertical line, that vertical line intersects the graph at only one point. So that means that for this x value, there's only one y value. For this x value, there's only one y value. So when x is 1, my y value is -3. No other y value, and so on. So this would be a function. Okay, in letter C, you have a set of ordered pairs. What you may want to do here is draw a mapping to kind of help you with this, so you have a visualization. And so this says that when x is -3, my y coordinate is 4. When x is 5, my y coordinate is 6. So 5 gets mapped to 6, -3 gets mapped to 4. When x is 4, the y coordinate associated with it is 4. So it's already here, so I'm going to draw it here. All right, so I'm going to take this one off. So if it's already listed, list it just once. Don't list it again. If x is -1, my y value is -2. Now, many students get confused about this. It is okay for the y value to occur more than once for two different x values, because it still satisfies the definition of function. Remember, for each x coordinate, there can only be one y coordinate. So when x is -3, the y coordinate is just 4. When x is 5, the y coordinate is just 6. When x is 8, the y coordinate is just 4. It's okay for 4 to occur more than once. If x is -1, the y value is -2. So this is a function. When you look at D, so when x is 7, my y value is -2. So 7 gets mapped to -2. 8 gets mapped to 2. So far we're okay. 7, oops, there's 7 again. Again, only list it once. Don't list it again, because then you'll not see the idea when you do this visually. So when 7 so 7, which you already have, also gets mapped to 4. Now you can stop here. You don't even have to look at these other points. If you have more points, you can stop, because notice that when x is 7, there are two y values. The definition of function says that for each x value, there can only be one y value. So when x is 7, there are two. So right away, this would not be a function. In letter E, you have to notice that, first of all, this is linear. So this is a linear function. And so if you notice that it was a linear function, the only, well, let me say this, it's a linear equation. The only linear equation that's not a function, the only linear equation that is not a function is a vertical line. So a vertical line is not a function. And remember, the equation of vertical line is always x equals some number. So the y value is not there. So that means that x is always going to equal that number. So for example, if x is 2, So if x is 2, that means that my x-coordinate is always 2, no matter what y is. And so if I graph it, if to the point 24 is here, let's say, and the point 20 is here, and the point 2 negative 1 is here, so I get this vertical line, and it fails the vertical line test. So when I draw a vertical line for this x value there's more than one y value. So the only line that is not a function is a vertical line. So all of the lines are functions. Lines with positive slope is a function, so these are functions. Lines with positive slopes are functions. Lines with negative slopes are functions. And lines that are horizontal, so line that has a slope of 0 is a function. But a line that's vertical, which has no slope, is not a function. So if you notice then that this is a linear equation and it's not x equal a number, so it's not vertical, then automatically you can say that's a function. Now what some of you may do is this, and this is fine, so what some of you may do is actually graph this and see what you get, and that's okay. So if you graph this, if you graph it, so 3x minus 2y equal 4, so you may want to write this in slope-intercept form. So let's put this in slope-intercept form. And so I'm going to add 2y to both sides. And so I get 3x equal 2y plus 4. Then I'm going to subtract 4 from both sides. And so I get 3x minus 4 equal 2y. And remember, to get this in slope-intercept form, that's y equals mx plus b. And so if I divide both sides by 2, I get, and reduce, I get y equals 3 halves x minus, and this is 4 over 2, which is 2. So that's in slope-intercept form. So if I use a t-table, and remember to graph a line, you just need 2 points. And so if I use a t-table, you'll notice that if x is, let's say, 0, then I get 3 halves times 0 minus 2, which is negative 2. So for this x value, there's only one y value, so far we're okay. If x is, let's say, 1, let's go ahead and use a 2, since this is the fraction here is 2, the denominator is 2, and so I'm going to use numbers that are divisible by 2. So if x is 2, I get 3 halves times 2, which is 3. 3 minus 2 is 1. So for this x value, there's only one y value. If x is, let's say, negative 2, 3 halves times a negative 2, that's what I'm saying, 3 halves times a negative 2, 2 into 2 is 1, 2 into negative 2 is negative 1, and this becomes negative 3. So a negative 3 and a negative 2 is a negative 5. So I get one y value when x is negative 2. If x is, let's say, 4, I get 3 halves times 4. 3 halves times 4. So 2 into 2 is 1, 2 into 4 is 2, so I get 6. 6 minus 2 is 4. So when x is 4, there's only one y value. And so on. So if I graph this, 0 and negative 2 is here. 2, 1 is here, let's say. I get this graph. And so notice it passes the vertical line test. Now when you do f, okay, so letter F, I have 3x plus y squared equal 4. Now this is a situation where what you've done in the previous course and what you've done in here at this point, you really haven't graphed this. An equation looks like this. So what you may want to do is first of all, let's go ahead and get y by itself. Now this is not linear, all right, so don't think that I'm putting this in slope-intercept form. When you get y by itself and it's slope-intercept form, then that means that this is linear. Y equals mx plus b. So remember, x is being raised to the first power, and y is being raised to the first power, so that makes it linear. But when I do this, when I get y by itself, notice what happens. Again, I'm going to subtract 3x from both sides. and so I get y squared equal 4 minus 3x. And then to get y by itself, I'm going to take the square root of both sides. So I'm going to go ahead and rewrite this over. And when I take the square root of both sides, you got to remember from a previous lesson that you have to remember that plus or minus. So that means that y, remember square root of y squared, the functions square root and square undo each other. So you get plus or minus, so you get a positive square root of 4 minus 3x and a negative square root of 4 minus 3x. Now notice what that means. Now remember, you haven't graphed anything like this, but notice what that means. So if x is, let's say, 0, if x is 0, I get plus or minus the square root of 4 minus 3 times 0. 3 times 0 is 0, so that becomes plus or minus the square root of 4, and that's just plus or minus 2. So this is plus or minus 2. Now remember what that means. That means that when x is 0, there are two y values. There's a positive 2 and negative 2, and then right away you can stop. This is not a function. All right, so you would not choose f. So the only in number 1, the only ones that are functions are a, c, and e. A, c, and e. Those are the only functions. Okay, so I just wanted to show you real quick the graph of this function right here. Graph of this function. 3x plus y squared equals 4. Here's the graph right here. And so notice, now that's the graph. So yeah, you're using Desmos, I had to do this part and then this part. So that's the graph. And so notice it fails the vertical line test. Okay. Now again, you didn't graph this in here, so there's no way you could have known how to graph this. But you didn't want to answer this using the idea of graphing anyway. You want to do it the way I just did it, by getting y by itself and plotting a few points or determining a few values. Okay, but this is what the graph looks like, and notice that it fails the vertical line test. Okay, so I just wanted to show you what the graph looked like. All right, when answering 2, it's just you remembering some a definition about consistent, inconsistent, dependent, independent systems. So in number 2, you're told that you have a system of linear equations, and that system has one solution. All right, so meaning in this particular case, remember what that means. That means that if you have a system of linear equation that has one solution, then when you graph it, it's going to intersect at just one point. So that's what that means. So you have this system that has this equation, and then you have this equation, and then since it has one solution, that means that they're going to intersect, and that's going to be your solution. All right, now when we talked about this, if a system has at least one solution, not an infinite, but a finite number of solutions, then that system is consistent and those equations are independent. All right, so that's a consistent. So a consistent system is a system that has at least one solution. Okay, so it has at least one solution, and independent means that for this particular case, those equations don't depend on each other. So basically, independent would be where it's not an infinite number of solutions. They don't overlap, let's say, don't overlap. All right, so dependent, consistent would be where consistent and dependent would be where you have an infinite number of solutions. So this would be infinite number of solutions. And you'll notice that the equations if you graph, would overlap when graphing. Okay, so that's the difference between these two. So, but but the answer is B, though. The answer is B. All right, so if it has one solution, not an infinite, but it has one solution, it is consistent and independent, and the equations are independent of each other. Inconsistent, remember, means that there's no solution. All right, so the answer is B for that one. Okay, so number 3, you wanted to solve the following system by elimination addition. Now remember, always follow directions, so this says elimination addition, not substitution. And again, you want to write the solution as an ordered pair. All right, so it's up to you whether you eliminate the x first or the y first. It does not matter. So I'm going to go ahead and eliminate the x. So I'm going to eliminate the x terms. Okay, so remember, if I'm going to eliminate the x terms, I've got to find the least common multiple of 8 and 6. And so the least common multiple of 8 and 6 is 24. And so also remember, at some point, I'm going to add those two equations, and I want those x values to be eliminated. So that also means that if I'm going to eliminate the x's, then the coefficients of these x's have to be opposites of each other. And so in other words, I'm going to go ahead and rewrite this over. So 8x plus 9y equal 13. 6x minus 5y equal 45. So in order to get a 24 here, I have to multiply both sides by 3. So I'm going to say times 3 times 3. And then over here, I'm going to have to multiply both sides by 4. Oops, sorry, by 4. So both sides by 4. But keep in mind that if I multiply, when I distribute, this is going to be 24x and this is going to be 24x as well. So I've got to make one of these negative. It does not matter which one. I'm going to do this one. So I'm going to multiply this by -3 and this by -3. Okay? All right, so now let's distribute. So I'm going from here to here now. -3 times 8x is a -24x. -3 times a positive 9 is a -27y. And then positive 13 times a -3 is a -39. The next one, 4 times 6x is 24x. 4 times a -5y is a -20y. And then 45 times 4, so 45 times 4 gives us 180. And now I'm going to add these two equations. So when I add the x terms, I get 0, which is what I wanted. So the x's are eliminated. So I'm going to end up with just an equation that has y in it. So -27y and a -20y is a -47y. A -39 and a positive 180 gives me 141. And so notice I have this linear equation with just one variable. So I'm going to divide both sides by -47. And then -47 divided by itself is 1. 1 times y is y. So I get y to be a -3. A positive divided by negative. A positive divided by negative is a negative. So I get -3. Now once I find my y coordinate, I got to determine what x. So far I know this. Remember, you want to write your solution as an ordered pair. So far I know this, that my y coordinate of my solution is -3. Okay, now to find the x coordinate, to find this x coordinate, you got to go back and substitute into one of these equations. Always go to the original and substitute in place of y, substitute -3. So I'm just going to go ahead and use the first one. So I'm going to substitute this value for y into the equation here where it's EOY. So I'm using substitution. That's part of elimination. So you got to substitute this value back into one of those equations. So I get 8x plus 9 times y. Y is a -3, and that's going to equal 13. So I get 8x minus 27 equals 13. Add 27 to both sides. Combine like terms. I get 8x equal 40. Divide both sides by 8. And then reduce. I get x to be 5. So that's your solution. So the solution is 5. Solution is 5, -3. All right, so that's your solution. And you can check, you can go back to the originals and substitute in place of x, substitute 5, in place of y, substitute -3. So if you notice, if you were to check this, and usually when a test is it's timed, you don't have time to do that. But if you did, you would just go back and wherever you see the variable x, you plug in 5. Wherever you see the variable y, you plug in -3. So I get 8 times 5 plus 9 times -3. I want to see if that's equal to 13. So 8 times 5 is 40, minus 27, and yes, that is equal to 13. And if I do the next one, 6 times 5 minus, that's a minus, 5 times -3, and I want to see if that's going to equal 45. Well, that's 30. A -5 times a -3 is a positive 15, and yes, that is equal to 45. All right, so 5 -3 is a solution. All right, number 4. This time you want to solve the system by substitution. All right, substitution. So make sure you follow directions. So remember, when using substitution, make sure you choose an equation that's going to make life easier for you, where there are no fractions involved. So in that case, the only equation that I would pick would be the equation x minus y equal -4. And since x already has a coefficient of 1, then I would just solve for x. If you solve for y, and it's fine, at some point you would have to divide by -1. So I'm going to choose x. So I'm going to get x equal, and then that's going to be y plus 4. X equal y plus 4. Okay, once you get so that was step 1. So once you solve for a variable, you're going to take this expression here, which is the expression for x, and you're going to substitute that into the other equation in place of x, because that's what I'm saying x equals. So x is going to equal y plus 4. So it goes here. So you get -2 times, in parentheses, y plus 4 plus 3y equal 6. And then if I distribute, I get -2y minus 8 plus 3y equals 6. Combine like terms, a -2y and 3y is y, so I get y minus 8 equals 6. And then add 8 to both sides. I now found my y value. So my y value is 14. Make sure, oops, I'm sorry. So see what I had, y plus 4? See, that's a -4, so that's y minus 4, excuse me. So let me go ahead and show you. So you get x minus y equal -4. So I'm going to add y to both sides. So get x equals y minus 4. All right, so I made a mistake there. So that'd be minus, that's going to be plus. That's still -2y plus 3y, still y, but that's going to be a minus, a plus 8. I'm subtract 8 from both sides, and so I get y to be -2, it looks like. Okay? All right, so -2. That's my y value. So now I'm going to substitute that y value back into either one of these equations. Does not matter which one, but since I already solved for x here, and I know it's correct. Now, remember, I could have made a mistake, and I did at first. But since I already have this for x, then I'm just going to substitute -2 into this equation. So -2 right here. So x equal -2 minus 4, which is a -6. So there's my solution. So my solution is -6, -2, and again, you want to write this as an ordered pair. Okay, number 5, you're given this function f of x, and you want to find function values. So I'm asking, if, remember, f of -3 means what's the y value when x is -3. That's what you're asked. So where you see the variable x, you're going to substitute -3. So right here, that's going to be 5 times -3 minus 7. So that's -15 minus 7, which is a -22. So f of -3 is a -22. So if you were to graph this function, that means that when x is -3, your y value would be -22. Okay, over here, now notice that when I evaluate a function, the functions we're dealing with, when I evaluate those functions at a number, I'm going to get a number. Here I'm evaluating the function f at 2x minus 1, at the expression 2x minus 1. So just like we did with part A, where we see the variable x, I want to substitute 2x minus 1. So again, wherever you see the variable x, that's what you're substituting. So I'm going to get 5 times the variable x, which I'm substituting 2x minus 1, and then I'm subtracting 7. So I'm going to distribute the 5, and so I get 10x minus 5 minus 7. So it becomes 10x minus 13. Oops, sorry, 12. So 10x minus 12. All right, so that's your answer. So f of 2x minus 1 is 10x minus 12. Okay, number 6. So you're given this function right here, and it's called g of x. So we're going to name it g of x. And you want to answer the following questions. Okay, so remember the domain is your set of x coordinates, and your range is a set of y coordinates. So when you're ever finding the domain, you go from along the x-axis, you go from left to right. And notice that this function, you have arrows pointing down, so it means that it's continually going like this. All right. So that means that for x equal 100, there's going to be a point on the graph. It'll be way down here. For x equal negative 1 million, there's going to be a point on the graph. So, and the same thing over here. If x equals positive 2 million, let's say this was 2 million, you get a point on the graph way down here. So the domain is going to be from negative infinity to infinity. Okay, so for each of those x values, remember what that means. For each of those x values, there's a y value. This x value, there's a y value. Way over here, for this x value, there is a y value. For this x value, there is a y value. So it's from negative infinity to infinity. All right, the range is a set of y coordinates. All right, so if you remember when finding the range, always go along the y-axis from bottom up. All right, so notice that these arrows are pointing downwards. So for the y value, let's say this was 100, negative 100, there's a point here and a point here. And so notice that for this function, I'm going from negative infinity all the way, and then notice I'm going to stop here at whatever this y value is. So this y value is 4. And notice that this point's on the graph. There's no open circle, so this point is on the graph, so I'm going to have to use bracket. So negative infinity with parentheses. Remember, infinity, negative infinity, always use parentheses with domain and range, 4 and a bracket. Okay, the directions also stated that to write the intercepts as an ordered pair. So for your x-intercepts, remember that's where the graph crosses the x-axis. There are 2 of them. So there's this one, so that's negative 4, 0. And remember, always write a point using parentheses. Okay, that represents a point. So it's got to be, your notation must be parentheses. And the other one is the origin, which is 0, 0. The y-intercept is where the graph crosses the y-axis. So here's my y-axis. That's where the graph crosses. It's the same thing as this x-intercept right here. That's the origin. All right, g of negative 1. So again, that means what's the y value when x is negative 1? So negative 1 is here. That's where x is. The point of the graph is here. So if I look at this, that is negative 1, 3. So when x is negative 1, a y value is 3. So the answer here is 3. In part F, you're asked, what's the x value where g of x is 4? Remember, g of x means y. So y is 4. Here's my y value right here. The only point in the graph I see is here. So remember this point right here, that represents the point negative 2, 4. So that's negative 2, 4. So then the question became, when y is 4, which is, this is the only place where y is 4, what's the x value? So the x value is negative 2. All right, so then we're going to talk about increasing, decreasing. So notice that when talking about the intervals where a function is increasing or decreasing, you're looking at the domain, at the x-coordinates. So the x-coordinates where my y values are increasing, and the x-coordinates where my y values are decreasing. That's what you're finding. All right, so you're not listing the intervals, you're not listing what your y values are, you're listing your x values. So you got to use your domain. And then when we talk about the intervals where a function is increasing or decreasing, it's always going to be open intervals. So we're going to use open intervals. Open intervals. So it's not like domain and range where you have to determine is it going to be a bracket or is it going to be a parentheses. Okay, so when you look at this at your function, so as you go from left to right, notice that as x increases here, so as I go from negative infinity to, I'm going to use this right here just to show you, so negative 2. So from negative infinity to negative 2, my y values are increasing. So notice your y value, each of those points, your y value is larger, getting larger and larger. And then from negative 2 to infinity, from negative 2 to infinity, and I forgot to put an arrow here, from negative 2 to infinity, in this interval, your y values are decreasing. All right, so where the intervals where my function is increasing, okay, there's only one, and so it's increasing from negative infinity to negative 2. So negative infinity to negative 2. So that's where a function is increasing, and then over here your function is decreasing. And so it's decreasing from negative 2 to infinity. All right, that was number 6. Number 7, all you were asked there was to determine the relative max and minimum. And so there, first of all, notice that in this particular function there are no, it's not constant anywhere. So notice that it's just like the number 6, your y values are increasing, then all of a sudden they're going to decrease, then increase. All right, so there's nothing that's constant. With the constant, most students get a little confused as to how to write the answers. Okay, so this is pretty straightforward then. So notice I'm going from increasing to decreasing, so that represents a relative. Remember, we're not talking about absolute at all in here. So that's a relative or local. So in this little local area right here, just a little piece, not overall, but this little piece, this is a relative max. So it goes from increase to decrease. Now I'm going to list it as the point. So the relative maximum point is negative 1, 6. Negative 1, 6. Then you're going from decreasing to increasing. So this relative min, so that's a minimum. So that's relative minimum point. And so your relative minimum point is, looks like it's 3, negative 26. All right, so it's hard to determine these negatives, but notice it's below the x-axis, so you have to see, even though you really can't see this negative in front of the 5, you have to know that since it's below the x-axis, those have to be negative numbers. Okay, so I found my points. I'm going to answer the question. So the relative minimum occurs when x is what? Well, x is 3. And the relative minimum value, so when you talk about value, you're talking about the y value. So the relative minimum value is negative 26. In B, you want to look at the relative max. So the relative max occurs when x is negative 1, and the value is going to be positive 6. So negative 1 and then 6. All right, number 8. So number 8, you're given a piecewise function, and you're just asked to find these function values. And so here, you're asked to find h of 2. Now remember, this is your domain right here. So if x is less than 2, remember that's your domain. So if x is less than 2, I'm going to use this function. If x is greater than or equal to 2, I'm going to use this function. So I want to find what what h of 2 is. So here you're indicating that x is 2. So if x is 2, I've got to use this domain here. So 2 occurs in this domain, so I'm going to use this function. So h of 2 would be 5 times 2 plus 1. So that's 10 plus 1, which is 11. All right, h of negative 1. So remember, this is negative 1 for x. So negative 1 for x is in this domain. So negative 1 is less than 2, so I have to use this function. So that's going to be 2 times negative 1, that's your x value, minus 5. So that's negative 2 minus 5, which is a negative 7. Over here, h is h of 5. So what's the y value when when x is 5? So I'm going to use this domain here because that's where 5 is greater than or equal to 2. So that's going to become 5 times 5 plus 1, 25 plus 1, which is 26. Okay, number 9, you want to graph this piecewise function. Okay, so remember how we did this. So you're going to graph each one individually, and remembering though, you got to use the domain that goes with it. So if I look at the first one, y equals x minus 3, and remember I've got to use, for my domain, I've got to use just numbers that are greater than or equal to 1. So if x is, and always start with the smallest x value. So x is greater than or equal to 1 here. So x, y. So if x is 1, I get 1 minus 3, which is a negative 2. So I'm going to plot the point 1, negative 2. Now remember, you have to determine whether and in both cases you're going to use 1. Remember we talked about that if this was, that in both cases, this is 1, so you use 1 in both cases. If this is 2, you can use 2 in both cases, and graphing both of these. But one's going to be an open interval, the other's going to be one's going to be an open circle, the other will be a closed circle. Since this is an equal to, this is going to be a closed point. So it'll be closed. So when I plot that point, 1, negative 2, I'm going to use a closed circle. Now remember, these are both linear pieces. So I just need one more point to graph the first one. So if x, and I got to use a number that's bigger than or equal to 1. So if x is, let's say, 3, I get 3 minus 3, which is 0. So I plot the point 3, 0, which is here. So then I graph the line. And actually, this is going to be a ray. And I get this. So that's that part of the piecewise function. Now when doing the other one, I'm still going to use 1. I'm going to have to find that value for this function when x is 1, but when I plot the point, it's going to be an open circle. It'll be an open circle. It'll be an open circle because there's no equal sign. So when x is 1, 2 times 1 is 2, 2 plus 1 is 3. So when I plot 1, 3 though, I put an open circle here. Now remember, f of x, so this is y equals 2x plus 1. So this is linear, so I just need one more point. Now when I graph it though, it's going to be a ray. It'll look like a ray. But a ray, I'm not going to call this a ray because this is open, because a ray has an endpoint, and it's closed endpoint. All right, so I need one more value for x. So we got to pick a value for x that's less than 1 though. So if x is, let's say, 0, I get 2 times 0, which is 0. 0 plus 1 is 1. So I get the point 0, 1, which is here. And then I just graph that part of the line. Okay, so there's your graph. All right, and notice it is a function because it does pass the vertical line test. All right, so that's number 9. Okay, number 10. Number 10, all you have to do is to determine the slope of the line that contains those 2 points. So remember, the slope formula is y2, it's rise over run. So y2 minus y1 over x2 minus x1. And it helps if you label these points. So let's call this the first point. So it'll be x1, y1, and this is the second point. So it'll be x2, y2. And then it's just plugging in these values into your formula. So the slope would be y2, which is negative 5, subtract y1, which is 2, divided by x2, which is negative 3. Now remember, the order matters. So if you started with y2, you better start with x2. So if you start with negative 5, you better start with negative 3 when you do the denominator. So negative 3 subtract a negative 8. So the numerator, negative 5 subtract negative 2 means negative 5 plus negative 2. The denominator, negative 3 subtract negative 8 means negative 3 plus 8. Remember, you always change subtraction to addition and take the opposite, so you add the opposite. So the opposite of positive 2 is a negative 2. The opposite of a negative 8 is a positive 8. And so this becomes a negative 7 divided by 5. So as your slope, negative 7/5. Okay, number 11, you want to graph this line. All you're told is the slope and the y-intercept. So remember, to graph a line, you need 2 points. I know one of them already. The y-intercept is a point of the line. So my y-intercept is at 4, so that's here. And then I'm going to use the idea of slope to find the other point. So remember, slope is rise over run. And in this case, my rise is negative 3, and my run's a positive 4. So you always start at the point that's given. So the point that's given is this y-intercept, so I'm going to start here. And so I'm going to go down 3 because my rise is negative, so I'll go down 3 since it's negative. 1, 2, 3. Now also keep in mind that when you graph this, the slope is negative. So if the slope is negative, remember your line is falling. So it should do something like this, not this. That's a positive slope. This is a negative slope. So I go down 3, and then my run is a positive 4, so I'm going to go to the right 4. 1, 2, 3, 4, and so there's the other point. And so I just graph my line, and you're done. All right, number 12. So number 12, you're given this linear equation, and you're writing in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So to get this equation in slope-intercept form, I get y by itself. So I'm going to go ahead and add 3 to x to both sides. And so I get 2y, when I combine like terms, that's 0. So 2y equals 3x minus 8. And then, remember, we got to get y by itself. So I'm going to divide both sides by 2, just like this. And then reduce. So 2 divided by 2 is 1. 1 times y is y. And I'm going to write this as 2 fractions. So that's 3/2 x. And then 8 divided by 2 is 4. So that would be minus 4. So that's your slope-intercept form. Y equals 3/2 x minus 4. Now remember, the coefficient of x is your slope. So the coefficient of x here is 3/2. So my slope is 3/2. Not 3/2 x, 3/2. Remember, it's just that coefficient of x. It's not the term, it's the coefficient of x. And then your constant is your y-intercept, so there's b. So my y-intercept is negative 4. And number 13, you want to graph this linear equation, but this time you want to graph it using intercepts. That's the only way you want to graph this. In one of the other problems, we graphed the line using a t-table. But here, don't use the t-table. Don't just pick any number for x. You got to make sure you're using following directions, and so they're asking for x and y-intercept. So remember, to find the x-intercept, remember, wherever you are on the x-axis, your y value is 0. So you let y equal 0. So wherever we see the variable y, I'm going to plug in 0. So I get negative 3x plus 4 times 0 equal 12. So negative 3x, so that's 0. So negative 3x equals 12. And then divide both sides by negative 3. And then reduce, I get my x-intercept to be a negative 4. So my graph is going to cross the x-axis at negative 4. 1, 2, 3, 4. So it's this one here, negative 4. But remember, though, you got to put your answer here, and it says indicate the intercepts as an ordered pair. So don't just put negative 4 here. Don't say that, because they're asking you to write as an ordered pair. So an ordered pair is a point. So my x-coordinate is 0, and my y-coordinate, you were told, is 0. I'm sorry, my x-coordinate is negative 4, and your y-coordinate is 0. Now to find the y-intercept, to find the y-intercept, you're going to let x equals 0. So no matter where you are on the y-axis, x is 0. So where we see the variable x, you can substitute 0. So you get negative 3 times 0 plus 4y equal 12. And then negative 3 times 0 is 0. 0 plus 4y is 4y equal 12. Divide both sides by 4. And then reduce. I get the y-intercept to be 3. So the y-intercept is 3. So that means that my graph is going to cross the y-axis at this point. And remember, your slope is positive. Your slope is positive 3/2, so you know it had to be increasing. Oops, sorry, I'm looking at the wrong one. So if I get y by itself, maybe I should have said that. So you don't have to, because you didn't have to know anything about slope to do this. But if you want to verify, you could have said 4y equal 3x plus 12. Divide both sides by 4. I get y equals 3/4 x plus 3. And so notice that your slope is positive 3/4. And so it better look like this. It better be increasing. All right, but again, you didn't have to do that. You didn't have to know anything about slope to do this problem. You just had to use, and you had to follow directions. It had to be intercepts. All right, and so there's your graph. That's all you had to do. All right, 14. Let's see what 14 is. Okay, so 14, you want to solve this exponential equation. Now, at this point, the only way you know how to solve an exponential equation is to get the bases to be the same. And so if you look at the base 8 here and the base 16 here, so you want to determine what number raised to a power be 8, what base raised to a power be 8, and when I do the 16, I'm going to have that same base raised to a power. So 8 and 16, if you try 4, you know that's not going to work, because even though 4 squared is 16, 4 raised to a whole number is not going to be 8. So you want to try 2 instead. So remember, 8 equals 2 cubed, and then 16 equals 2 to the 4th power. So you want to use 2 as your base. All right, now be careful you write this. So 8 is 2 cubed, but that's being raised to the 2x minus 3 power. And then that's 16 is 2 to the 4th, and that's being raised to the x plus 2 power. Now remember, when you have a power raised to power, you multiply those powers. So you multiply these together. So you have to use the distributive property. 3 times 2x minus 3, that's what you're saying. 3 times 2x minus 3. Oops, sorry, minus 3. That's what this is. So you get 6x minus 9. So that becomes 2 to the 6x minus 9 power. Over here, that becomes 4 when your power is the power you multiply them. So it'll be 4 times x plus 2. And then when you distribute, that's 4x plus 8. So that'll be 2 to the 4x plus 8 power. And now remember, when you have an exponential equation, the bases are the same. The only way that those two sides are equal to each other, if the bases are the same, then the exponents have to be equal to each other. So then all you do is set the exponents equal to each other. I get 6x minus 9 equal 4x plus 8. So notice I went from this exponential equation to solving a linear equation. So whatever solution this is going to be a solution to the original problem. Alright, so since this is linear, I'm going to bring all the variables to one side. So I'm going to subtract 4x on both sides. So I get 6x minus 4x is 2x minus 9 equal, and then on this side, that's 0 plus 8, which is 8. Add 9 to both sides. Combine like terms, I get 2x equals 17. Divide both sides by 2. I get x to be 17 halves. So there's your solution, 17 halves. Okay, 15, you want to graph y equals x squared minus 4. Now when graphing 15, you got to recognize what kind of solution, what kind of equation this is. This is a quadratic equation. I even tell you that's a quadratic equation. It's not linear, so don't draw a line. Don't find 2 points and then draw a line, because that's not a linear equation. That's a quadratic function. So the graph is a parabola. And all we've done at this point with graphing quadratics is this kind, and so remember it probably looks like this. It could go up or it could go down. All right. But at any point you needed more than 2 points to help you graph this. So if x is 0, I get 0 squared minus 4. So it's 0 squared 0. 0 minus 4 is a negative 4. So I'm going to plot the point 0, negative 4, which is here. If x is, let's say, 1, so if x is 1, I get 1 squared minus 4, so I'm finding the y value. So 1 squared minus 4, so that's 1 minus 4, which is a negative 3. So I'll plot the point 1, negative 3. Again, don't stop there and draw a line. That's not linear, that's quadratic. If x is, let's say, negative 1, I got a negative 1 in parentheses, put it in parentheses, squared minus 4. Negative 1 times itself is 1. 1 minus 4 is a negative 3. So I get negative 1, negative 3. So notice you're going to notice that that's not a line because these 3 points don't lie in the same line. If x is 2, I get 2 squared minus 4. So that's 4 minus 4, which is 0. So I get 2, 0, which is here. If x is, let's say, negative 2, I get negative 2 in parentheses squared minus 4. So that's 4 minus 4, which is 0. It's negative 0. And noticing that this is quadratic, so the graph is a parabola, you get something that's going to look like this. So do the best you can with drawing it. Make it look symmetrical. And that's it. That's all you had to do. Okay, in 16, you want to perform the indicate operations, and you want to write the answer in standard form. Now we are dealing with complex numbers with the number I, so in standard form that means a plus bi. All right, so I'm going to use the fall method here since this factor has 2 terms and this has 2 terms. So 6 times 3 is 18. The outer is 6 times a negative 5i is a negative 30i. The inner, a negative I times 3 is a negative 3i. And then a negative I times a negative 5i is a positive 5i squared. Now that I squared, you got to remember that I squared is equal to a negative 1. That's what I squared equals to. Remember, I is the square root of a negative 1. So the imaginary unit. So that's not a real number because you can't take the square root of a negative number. So this is an imaginary unit. That's an imaginary number. But you do have to remember that I squared does equal negative 1. And so in place of I squared, you're going to substitute negative 1. That's what you have to do here. And so this becomes 18, a negative 30i, and a negative 3i is a negative 33i. And then that becomes plus 5 times a negative 1. And so I get 18 minus 33i, positive 5 times a negative 1 is a negative 5. And so 18 minus 5, I can combine like terms. So that'd be 13 minus 33i. So 13 minus 33i. So that's what that equals to. 17, you want to divide these 2 complex numbers. So remember, when dividing complex numbers, you want the denominator. See how this is a complex number with the imaginary unit, I. You want this to be a real number down here. So in order to make this a real number, to get rid of that I, I've got to multiply numerator and denominator by the conjugate. You have to use conjugate of the denominator. So the conjugate of 3 plus 2i is 3 minus 2i. And so you have to say negative 3i divided by 3 plus 2i, and then multiply both the numerator and the denominator by the conjugate of the denominator. And so now this becomes, right, this is one fraction, so this becomes negative 3i times 3 minus 2i divided by 3 plus 2i times 3 minus 2i. And so when I distribute up here, I'm going to get negative 3i times 3 is a negative 9i. A negative 3i times a negative 2i is a positive 6i squared. I squared. Because I times I is I squared. And remember the fact that I squared equals a negative 1. We have to use that fact. Down here, we use the fall method. So 3 times 3 is 9. Now remember, when you multiplying conjugates, two binomials that are conjugates of each other, the outer and inner will cancel, and they do, because notice this, the outer is a negative 6i, the inner is a positive 6i, and notice that when you add them up, you get 0. A positive 2i, so let's look at the last, a positive 2i times a negative 2i is a negative 4i squared. All right, now remember, I squared is a negative 1. I'm going to replace I squared with negative 1. So I'm going to go off over here and write that out. So that's going to equal negative 9i plus 6 times a negative 1 divided by 9 minus 4 times a negative 1. So negative 6, so that becomes negative 9i minus 6 divided by 9, a negative 4 times a negative 1 is a positive 4. And remember, you want to write it in standard form. So I'm going to do this first. I'm going to put negative 6 first. It'll be negative 6 minus 9i divided by 13. And then in standard form, that becomes negative 6/13 minus 9/13 I. All right, so that's your answer for number 17. Okay, number 18, this one's multiple choice. You're told that the center of the circle is negative 3, 5. So h is negative 3. K is 5, and your radius is square root of 5. So there's your radius. And you want to, and it says which of the following equations represents this information. And now notice that all these are in standard form for the equation of a circle. So the equation of a circle, remember, is x minus h squared plus y minus k squared equals r squared. So this is your h, this is your y, and then this is your r. So in place of h, k, and r, I'm going to substitute those values. So I get x minus h, which is a negative 3 squared, plus y minus k, which is 5 squared, equals r, which is a square root of 5 squared. So x minus negative 3, that becomes x plus 3 squared, plus y minus 5 squared, and then the square root of 5 times the square root of 5 is square root of 25, which is just 5. And so that's going to be your answer, so you look for this one. So the one that applies here is C. So C is your answer. Okay, number 19, you're given the general form of the equation of a circle, and you want to write it in standard form, so you want to get it that form. Well, remember, when you have the general form and you want to put it in standard form, you have to use completing the square. Okay, you have to use completing the square. So you're going to complete the square in the x's, and you can complete the square in the y's. Now, before you do all that, you got to make sure that your constant's on the other side. And also make sure that x squared and y squared both have a coefficient of 1. And that's all we've done anyway, with coefficients of 1s for x squared and y squared. Okay, so you can put all the x's together. So you can say x squared minus 6x. So every term that has an x, you put it together. Plus some number you're going to add. So when you complete the square in the x's, you're going to have to add something to both sides. And then plus y squared plus 4y. And then leave some space because you're going to be adding a number. And that's going to equal, when you add 3 to both sides, it becomes 3. So you're going to add 3 to both sides to get the constant to the other side. So if this was plus 3, then this would be a negative 3. Okay, now let's complete the square in the x's. To complete the square in the x's, you've got to make sure that the coefficient of x squared is 1, though, and it is. You're going to take the coefficient of x, which is negative 6. You're going to take half of that. Whatever that is, you're going to square. All right, so here's what we get. Negative 6 halves is a negative 3. Negative 3 squared is 9. And that's what you add to both sides. So what you do to one side, you have to do to the other. You got to keep it balanced. Now, once you do that, remember the whole idea is that this is now a perfect square trinomial. So that means that you can factor this as a binomial squared. And so now these are always going to be plus right here when you add a number to both sides. But when you factor, don't say that's x plus 3 squared, because your middle term is negative. The only way you can get this to be negative 6x is if you say x minus 3 squared. All right, over here you're going to take the coefficient of 4, take half of that, and then square. So that's 4 divided by 2 is 2, squared is 4. And here you're going to add 4 to both sides. And now this is now a perfect square trinomial, so you can get y plus 2 squared. All right, so if you follow this out, you can get this back. And that's going to equal, and then all you do is just add these numbers. 3 plus 9 is 12. 12 plus 4 is 16. So there's your answer. So x minus 3 squared plus y plus 2 squared equal 16. All right, number 20. Number 20, you want to graph the equation. You want to graph the circle. And it's already written in standard form, so it'll make things a lot easier. So remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared. And so let's look at this part right here first. So I want you to, don't say the center. The center is not 2, negative 3. That's not the center. You remember, it's got to be in the form x minus h. So right here, when I look at this, that's x minus a negative 2 is x plus 2. So h is negative 2. So that is the center, the x-coordinate of the center of the circle, negative 2. And then here, that's going to be plus y minus 3. So it's already in the form y minus. So that means that k is 3. So your center is negative 2, 3. That's your center. So negative 2, 3 right here. Now you got to find the radius. Remember, in the equation of a circle, that number here is r squared. So that means that r squared equals 36. And so to get r by itself, you can take the square root of 36. Don't do plus or minus because you are dealing with distances here. So just do the positive square root, the principal square root. So r is 6. So that's your radius. So if I'm going to graph this, remember, we're going to use the radius, which is 6, to help me graph this. I'm going to go 6 units to the right. 1, 2, 3, 4, 5, 6. I'm going to go 6 units up. 1, 2, 3, 4, 5, 6. 6 units to the left. 1, 2, 3, 4, 5, 6. 6 units down. 1, 2, 3, 4, 5, 6. And then just connect these using a circle. Do the best you can with drawing this. All right, so there's your circle. Now the domain, remember, is a set of x coordinates. The range is a set of y coordinates. So domain, you go from left to right. So when I go from left to right, I start touching the graph here, right here. So that's the x coordinate negative 8. Now remember, there's no open circles at all here, so these all be brackets. So bracket negative 8, 2, and then you stop here at 4. Your range is a set of y coordinates, so you go from bottom up. So I start touching the graph at this y value right here. That's negative 3. All the way to, you keep on going, all the way to positive 7, 8, 9, positive 9. All right, so that's number 20. Okay, 21. All right, that's a little bit more involved here because all you're given are the endpoints of a circle, the diameter of a circle. And so you want to write the equation in standard form. So if you're going to write the equation of a circle in standard form, and here's the equation, x minus h squared plus y minus k squared equals r squared, then you got to know two things. You got to know the center, and you have to know the radius. And you don't know any of those. But you do know that these 2 points are the endpoints of the diameter of a circle. And a circle, remember, if you look at even this one, a circle, now this will be the diameter. Remember, the diameter goes to the center. So no matter where you are on the circle, if you draw a segment that goes through the center and the endpoints lie in the circle, those are all diameters. So there's an infinite number of diameters. But the point I'm making with this one, though, is that the diameter goes through the center. So this diameter, which is a segment, goes through the center. Well, this center is the midpoint of the diameter. So if you're told that the endpoints of the diameter are here, so if you're going to find the center of the circle, that's going to be the same as the midpoint of this diameter. So the midpoint formula, you have to use the midpoint formula. So the midpoint formula, it's a point, so you're going to need parentheses. That's where you add your x coordinates together, divide by 2. So x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. All right? So let's label this x1, y1, x2, y2. So I add my x's together. So remember, finding the midpoint. So the midpoint will be the center of the circle. The midpoint will be the center of the circle. All right, so I get x1 plus x2. So I get -4 plus -2 divided by 2, comma, and then you add your y's. 2 plus 6 divided by 2. So it becomes -4 plus -2 is -6 divided by 2, and then 2 plus 6 is 8, 8 divided by 2. So that becomes a -3, 4. So there's your h, there's your k. So the only thing I have to find now is the radius. That's the only thing I left to have to find. Well, remember, if this is your diameter right here, if that's one of them, and there's an infinite number of these, but if you look at this, the radius, remember, is the length from the center to a point on the circle. So there's an infinite number of radii. But if you go back and look at the diameter, this diameter right here, the radius is half of the diameter. So the radius, the length of the radius, is 1/2 the length of the diameter. So if I want to find the length of the radius, then all I need to do is find the length of the diameter. So I'm going to use the distance formula to find the length of the diameter. So the length of the diameter you use the distance formula. So remember, the distance is square root of, and you're going to do the x's first. It does not matter what order you put the x's because you're squaring it. So it does not matter. So x2 minus x1 squared plus, and then y2 minus y1 squared. So let's plug in. So the length of the diameter here is going to be the square root of, in parentheses, x2, which is -2, minus x1, which is -4 squared, plus, and then y2, which is 6, subtract y1, which is 2 squared. So this becomes the square root of -2 plus 4 squared. And then this 6 minus 2 is 4, 4 squared. So that becomes the square root of -2 plus 4 is 2, so it becomes 2 squared plus 16. So that becomes 4 plus 16, which is the square root of 20. All right, so that's what I get there, it's square root of 20. All right, now, okay, so that's the length of the diameter. So the radius then of the circle is going to be half of this. So it'll be the square root of 20 divided by 2. All right, now don't make a mistake and say 2 into 20 is 10, because this is irrational. That's not 20. That's the square root of 20. Now this is 20 divided by 2, then that would be 10. But the numerator is an irrational number, and the denominator is a rational number. You cannot reduce this. You can't say 2 into 2 is 1, 2 into 20 is 10, because that is not a 20 right here. That's a square root of 20. So leave it like this. And don't even simplify the square root of 20 here, because when you, at some point, you have to square it. So what I have is this. If I go back and substitute values into here, I get this. I get x minus h. H is -3 squared, plus y minus k. K is 4 squared, equals the radius, which I found to be this, but I got to square it. Now simplify this and put that as your answer. So x subtract -3, remember, is x plus 3. You got to write it like that. plus y minus 4 squared equal, and then over here, there's the square root of 20 divided by 2 times itself. That's what that means. So the square root of 20 times the square root of 20 is 20. 2 times 2 is 4, and 20 divided by 4 is 5. So it becomes 5. And that's what you put in the blank. So x plus 3 squared plus y minus 4 squared equal 5. Okay, 22. You want to find the distance between these 2 points. So you already know the distance formula right here. So let's call this x1, y1, x2, y2. And so the distance will be the square root of, and then when you subtract your x coordinates, it'll be 4, subtract this x coordinate, which is 0, squared, plus, and then you subtract your y coordinates and square them. Negative 2 minus 2 squared. So 4 minus 0 is 4, so we get the square root of 4 squared, plus, now be careful, that's not 0 right here. A negative 2 and a negative 2 is a negative 4 squared. So it becomes 4 squared is 16, plus a negative 4 times itself is also 16, so you get the square root of 32. Now note square root of 32 is not listed anywhere in here. That's because you have to simplify the square root of 32. Now always look for the largest perfect square that goes into 32. So the largest perfect square that goes into 32 is 16. So square root of 32 is the square root of 16 times 2. And so I can write this square root of 16 times the square root of 2, so it becomes 4 square root of 2. So 4 square root of 2 is c. So c goes there. Now, you didn't have to use the largest perfect square. You could use another perfect square that goes into 32, like, for example, 4. So you'd have a little bit of more steps to do, though. So you would have the square root of 32 is the square root of 4 times 8. So the square root of 4 times the square root of 8, so that's 2 square root of 8. But notice 2 square root of 8 isn't listed anywhere here. So that means you got to simplify the square root of 8 further. Well, another perfect square that goes into 8 is 4. So I'm going to rewrite this here. So it becomes 2 times the square root of 4 times 2, because 4 times 2 is 8. And then it becomes 2 times the square root of 4 times the square root of 2. Square root of 4 is 2, so it'll be 2 times 2 times square root of 2, so that's 4 square root of 2. 2 times 2 is 4. That's what that says. C. All right. Number 23. 23, you have this compound inequality, and it's not a difficult one. You just got to get the variable x by itself. So I'm going to subtract 2 from all parts, and so I get negative 6 is less than 3x. It's less than or equal to 9. And then finally divide both sides by 3, or divide all parts by 3, and so I get negative 2. Negative 6 divided by 3 is negative 2. It's less than x, because 3 divided by 3 is 1, and it's less than or equal to 3. So your solutions to the original inequality, this original compound inequality, would be any number between negative 2 and 3. All right, now notice that there's no equal sign here, so I'm going to use a parentheses, a negative 2, and a bracket. Since there is an equal sign, that means that 3 is a solution, negative 2 is not a solution. And then you shade in every number between them. So all these points that are shaded are solutions to the original inequality. So in interval notation, you just say parentheses negative 2, comma, and then, oops, I put the wrong one right here, sorry. So this one. All right, so bracket's at 3. So 3 with a bracket. Now over here, this is an absolute value inequality, but it's a less than. So remember, if it's a less than, that's where you're going to write it as a compound inequality that looks just like this. So you're going to say 2x minus 3 is less than or equal to 7, and at the same time, that expression has to be bigger than or equal to negative 7. And so you're going to add 3 to both sides. And so I get negative 7 plus 3 is a negative 4. Is less than or equal to 2x is less than or equal to 10. And then divide both sides by, divide all parts by 2. I get negative 2 is less than or equal to x is less than or equal to 5. So your solution would be any number between negative 2, now those are all brackets because of the equal signs, and 5. And so I get bracket -2, comma, 5 with a bracket. All right, now just to remind you, another way you could have done that was writing as two separate inequalities, but you got to be careful. Remember, when you solve an absolute value inequality that has only one inequality symbol, that doesn't look like this, but has one inequality symbol, that's where you either use an or statement or an and statement. If it's a less than, that's an and statement. So this becomes 2x minus 3 is less than or equal to 7, and at the same time, 2x minus 3 has to be bigger than or equal to -7. Kind of makes sense because when we wrote it like this, we said 2x minus 3 has to be bigger than or equal to -7. That's what this is. And when you write a compound inequality that looks like this, you are talking about an and statement. So remember, this says 3x plus 2 has to be less than or equal to 11, and at the same time, notice the phrase, and at the same time, 3x plus 2 has to be bigger than, greater than -4. So that's an and statement. And so you would solve each inequality individually. So you'd say 2x is less than or equal to 10, divided by 2, so I get x is less than or equal to 5. Over here, add 3 to both sides, combine like terms, I get, that's a 0 here. So I get 2x is greater than or equal to -4, divide both sides by 2, I get x is greater than or equal to -2. Now what you found is this. Over here, if I shade in all solutions, all numbers that are less than or equal to 5, let's say this is 5, and I shade it in, bracket to the left, those are my solutions to this inequality. The solution to this inequality right here would be any number that's greater than -2. But I want to find the solution to the original inequality. The solution to the original inequality, remember that's an and statement, is the intersection of those two. Where do the two graphs overlap? So that's the solution. So they overlap from -2 to +5, and that's what this is. So if you did not do it this way, which is the way we did it in class, we emphasized in class, then you could have split it apart, but remember that's an and statement, so you had to use the word and you had to recognize that you are graphing, the solutions would be the intersection of the two. Also keep in mind that usually when students, for the most part, there are some students that forget that even though they remember the and, they'll not say greater than or equal to -7, they'll say less than or equal to -7, and it's not. One is less than equal to, the other is greater than equal to. Okay? All right, 25. You want to solve this absolute value equation. Now remember, this is not a linear equation, that's an absolute value equation. So when you're solving an absolute value equation, you're gonna get two equations without the absolute value bars. So make sure your next step is to rewrite this without the absolute value bars. And so we learned that for an absolute value equation, and notice the absolute value bars are already by themselves, so that's easy to deal with. You're just going to say 4x minus 1 equals 13. Remember, without the absolute value bars. And then 4x minus 1 equals a -13. And then notice I went from this absolute value equation to two linear equations. So then you add 1 to both sides. So I get 4x equal 14. Divide both sides by 4. And then reduce. I get x to be 7/2. So there's one of your solutions, 7/2. Now don't put parentheses here, because you put parentheses, if you're gonna use something, a notation, you can use a brace, because that represents a set. So my solution set will be set notation. So brace 7/2, and over here add 1 to both sides. I get 4x equal -12. Divide both sides by 4, and then reduce. I get x to be a -3. So my solutions is a set 7/2 and -3. You could also set x equals 7/2, comma, x equal -3. Does not matter. Okay, in 26, you have this linear equation. The denominators are all whole numbers. So when solving a linear equation, you have fractions in it. You want to find the LCD. So you're going to clear the fractions using the LCD. So the LCD of 4, 6, and 2 is 12. So the LCD is 12. So you can multiply both sides by 12. Now, since the left side had two fractions, I'm going to put that in parentheses. So 3x minus 7 divided by 4 minus 5 divided by 6. And over here, that's x divided by 2. So, and then we'll multiply both sides by 12. So times 12 times 12. Now here I'm going to distribute the 12 because both of these fractions have to be multiplied by 12. So you get 12 times 3x minus 7 divided by 4 minus 12 times 5 over 6 equals 12 times x over 2. All right, so that's what it had. So all I did was distribute the 12 here. So 12 times this, 12 times this. You distribute first, don't reduce first. Don't make the mistake and say 4 into 12 is 3 and distribute it 3, because you notice that 5, 6 is not being multiplied by 3. 5, 6 is being multiplied by 12. Okay, now let's reduce. 4 into 4 is 1. 4 into 12 is 3, but be careful here, because that 3 has to be multiplied by this numerator, by both terms here. So put that in parentheses. Over here, 6 into 6 is 1, 6 into 12 is 2, so 2 times 5 is 10. Over here, 2 into 2 is 1, 2 into 12 is 6, that becomes 6x. Distributing, I get 9x minus 21 minus 10 equals 6x. Combine like terms, I get 9x minus 31 equals 6x. Let's bring the 6x, actually we could have subtracted 9x if you wanted to. So if you subtract 9x from both sides, I get, and then combine like terms, I get negative 31 equals a negative 3x. Divide both sides by negative 3, and then reduce. Negative 3 divided by negative 3 is 1. 1 times x is x. And then negative divided by negative is a positive. Remember that. So that would be a positive 31 thirds. Now let me just say this. Over here, when we had 9x minus 3, let me put an R here, minus 31 equals 6x. If you wanted to, you could have subtracted 6x from both sides, and that becomes 3x minus 31 equals 0. Then add 31 to both sides. Combine like terms, I get 3x equals 31, and then divide by 3, and you get the same answer. So your approach does not matter. The approach you take did not matter at this point. You get the same answer. 27. Okay, 27. Now this time you have a rational equation because you have variables in the denominator. So you got to clear the fractions just like we did in the previous problem, but the LCD is not going to be a real number. It's not going to be a real number like we had here. So what you need to do, first of all, is make sure that all your denominators are factored. So x plus 5, there's nothing else I can do to it. It's in factored form. It's prime. X minus 4 is in factored form. It's prime. But x squared plus x minus 20, I can factor that. When you factor that, x squared plus x minus 20, you're going to get x plus 5 times x minus 4, which is what these are. So this problem becomes a lot easier because of the fact that when I factor this trinomial, I get these two denominators. So your LCD must include every factor you see. So I see an x plus 5. So remember, the whole purpose of multiplying by the LCD, remember, is to clear your fractions. So if I want to make this a 1 down here, the idea is to have these denominators be 1s. That means I got to multiply by x plus 5 at some point here to reduce these. So that means your LCD has to be an x plus 5 in it. Same thing here. If I want to clear this x minus 4, make that a 1, then I got to multiply by x minus 4. And over here, the x plus 5, same thing. I already have it. And then x minus 4, I already have it. So there's your LCD. So your LCD is just this. Now, before we go on, let's find the restrictions. So remember, your restricted values, you cannot divide by 0. So then you got to ask yourself, if x plus 5 equals 0, then what x makes that 0? So what x makes that 0 is a negative 5. So one of your restrictions is that x cannot equal a negative 5. Your other restriction, x minus 4, cannot be 0. But where is x? What is x? What x makes this denominator 0? That's your question. So you're going to add 4 to both sides. And so x is 4 is where this is 0. So you can't have 4 either. So your restricted values is x cannot be 5 and x cannot be 4. And then over here, those are the same ones. So you set each one equal to 0, you're going to get these numbers also. All right, now let's do the work. So we're going to multiply both sides by the LCD just like we did in number 26. All right, so since I have two fractions on the right side, I'm going to put that in parentheses. So 5 divided by x plus 5 minus 2 divided by x minus 4. That side has to be multiplied by the LCD, which is x plus 5 times x minus 4. And remember, what you do to one side, you have to do the other. So if I multiply this side by the LCD, I've got to multiply the other side by the LCD. So the other side was negative 18 divided by x squared. I'm going to put the factored form. So x plus 5 times x minus 4. So I'm going to multiply this side by the LCD as well. X plus 5 times x minus 4. Okay, now over here I'm going to distribute. I'm going to get rid of the parentheses. So I have the LCD times the first fraction. So x plus 5 times x minus 4 times the first fraction minus the LCD times the second fraction. X plus 5 times x minus 4 times the second fraction equal. Over here I'm just going to go ahead and reduce. So the x plus 5's divide out. The x minus 4's divide out. And remember, that was the whole point. The whole point of multiplying by the LCD is to get these down here to be 1s. So 1 times a negative 18 is a negative 18. All right, over here, I'm going to go ahead and distribute. So remember, the whole point of multiplying by the LCD is to make these 1s. So let's go ahead and reduce. So there'll be x plus 5 is 1. So those divide out. So I'm left with 5 times x minus 4. I'm not going to distribute yet. Let's just write it 5 times x minus 4. So that's what this says. 1 times x minus 4 times 5 is 5 times x minus 4. Minus over here, if I reduce first, the x minus 4's divide out. Notice that's a 1 down here. That's what you wanted. X plus 5 times 1 times 2 is 2 times x plus 5. But don't forget, that's a subtraction right here. Equal negative 18. All right, now let's distribute. So I'm going to distribute these numbers. I get 5x minus 20 minus 2x minus 10 equal negative 18. Combine like terms, 5x and a negative 2x is 3x. A negative 20 and a negative 10 is a negative 30 equal negative 18. So notice I went from this rational equation to a linear equation. Okay, now I'm going to add 30 to both sides. And when I combine like terms, I get 3x equal a negative 20, negative 12. So negative 12, that's negative 12. Divide both sides by 3, I get x to be negative 4. That's positive 12. And negative 18 plus 30 is 12, so that's positive 4. Positive 4. Okay, now many students they're going to just say the solution is 4, but you got to remember this was a rational equation, and you can't have 0 in the denominator. So if you notice, 4 was one of the restrictions. So that means that if I plug in 4 into the original problem, at some point down here I'm going to have a negative 2 divided by 0, because 4 minus 4 is 0, and you can't divide by 0. So that means that 4 is not a solution. So remember, you may say, well, 4 is a solution because when I solved for x, I got 4. Yes, 4 is a solution to this linear equation, but 4 is not a solution to the rational equation. So remember, that's called an extraneous root. An extraneous root, extraneous solution. All right, so think false. It's a false solution. So it satisfies this equation, but it doesn't satisfy the original because we can't divide by 0. So then you just say no solution. That's all you do. No solution. Okay. 28, you want to solve this equation by factoring. So notice, though, this is quadratic. And so if I'm going to solve this by factoring, at some point, I'm going to have to use the zero factor property. So meaning that I've got to have 0 on the other side. So when I rewrite this, I'm going to subtract 15 from both sides. So I'm going to get 4x squared plus 4x minus 15 equal 0. All right, and so in a previous course, you learned all about factoring. And so I'm going to factor this into two binomials. The GCF here of the left side is 1, so that's why I didn't factor out anything. So I'm going to go directly to two binomials. So this is a trinomial, it's quadratic, trifoiling, the opposite, the idea of foiling. So 2x times 2x is 4x squared. 15, there are two possibilities. There's 5 and 3, negative 15 and 1. So let's do 5 and 3. Now, see, so these terms here these first terms are the same. It doesn't matter where I put the 5 and where I put the 3. It does not matter. But I do have to remember that the last sign is negative, so that means that these signs are going to be different. So the one that's going to work, remember I want the middle term to be remember when I fall, I get the outer and the inner. So I want that middle term to be a positive 4x. If you look at the outer is 6x here. The inner is 10x. The larger 10x gets this middle sign. So that has to be plus and that has to be negative. So that means that this becomes 2x plus 5 and this becomes 2x minus 3. All right, now many students make a mistake and they'll say the solutions is this. Well, that's not the solution. Remember, the solution is where you tell me what x equals. What number for x will make the left side equal to the right side? That's what you have to find. So don't just factor and say that's your answer. I didn't say factor this trinomial, this quadratic expression. I said factor. I said solve this equation. So you got to solve an equation. So you got to set each of those factors equal to 0. That's where you're using the zero factor property now. So if you have two factors whose product is 0, then one of those has to be 0. So you say 2x plus 5 equals 0, and then 2x minus 3 equals 0. And then you notice these are linear, so you just solve for x. So you subtract 5 from both sides, you get 2x equal negative 5, so x is negative 5 halves. There's one of your solutions. So x equal negative 5 halves. Your other solution, you're going to add 3 to both sides. So I get 2x equal 3 divided by 2. The other solution is 3 halves. So those are your solutions. So x equal negative 5 halves, comma, 3 halves. Or you could have written as a set, negative 5 halves, comma, 3 halves. You could have said x equal negative 5 halves, comma, x equal 3 halves. Does not matter. But don't put it as a point. Don't say this, though. 5 halves, 3 halves. Don't do that, because that represents a point. All right? So you write it like this instead, one of these ways. Now, some students will say this, 5 halves, comma, 3 halves. Oops, sorry, negative 5 halves. That's fine. Just as long as you don't indicate with parentheses, because that represents a point, that represents an interval. All right, so make sure mathematically you write things correctly. Okay, number 29, the very last one. You want to solve this quadratic equation by using a quadratic formula. All right, so it's already in standard form or general form, so that's where every term's on one side, zeros on the other. So remember, the quadratic formula is the square root, plus a negative b plus or minus the square root of b squared minus 4ac all over 2a. That's your quadratic formula. So if I'm going to use the quadratic formula, I've got to know a, b, and c. So a is a coefficient of x squared, so a is 2 here. B is the coefficient of x, so the coefficient of x is negative 4, that's b. So b is negative 4. And c is your constant, negative 1. All right, and so you just plug those values back into here. Now you got to make sure that before you substitute that these are correct. All right, so you can say x equal, that's your variable, x will be the opposite of b. Well, b is negative 4. The opposite of negative 4 is a positive 4. Plus or minus the square root of b, which is negative 4 squared, minus 4 times a is 2, times c, which is negative 1, all over 2 times a, and a is 2. So let's simplify the radicand. So I get 4 plus or minus the square root of negative 4 squared is a positive 16. A negative 4 times a positive 2 times a negative 1 is a positive 8, all over 4. So that's 4 plus or minus the square root of 16 plus 8 is 24 divided by 4. All right, now you want to simplify the radical. You want to simplify if possible. So I can simplify the square root of 24 because the largest perfect square that goes into 24 is 4. So that's 4 times 6. So it becomes the square root of 4 times the square root of 6. So that's 2 square root of 6. So I'm going to replace the square root of 24 with this. So it becomes 4 plus or minus 2 square root of 6 all over 4. And then you reduce. Notice that 4, 2, and 4, they're all divisible by 2. So you're going to write your answer as 2 plus or minus. So that's 2, that's 1, that's 2. So square root of 6 all over 2. All right? Now, you could have also had this point right here, say 4 divided by 4 plus or minus 2 square root of 6 divided by 4, and then reduce. So that would have been 1 plus or minus the square root of 6 over 2. All right, so either one of those is fine. 1 plus or minus square root of 6 divided by 2. You could have split it apart into two solutions. So you could have said 2 plus the square root of 6 divided by 2, 2 minus the square root of 6 divided by 2, and the same thing here. 1 plus the square root of 6 divided by 2, 1 minus the square root of 6 divided by 2. So these are all different ways of writing the solution, either this one, this one, this one, this one. You could have also broken it down into two fractions like this. You could have said 2 divided by 2 is 1, plus the square root of 6 divided by 2. 2 divided by 2 is 1, minus the square root of 6 divided by, 1 minus the square root of 6 divided by 2. So, So either this, or this. All right, so different ways of writing this solution, but you have to make sure that it was simplified though, because it did say simplified. All right, so that's the key to test 1.